This is lesson 2.2 of our Precalc 11 class. Unit 2 is called Polynomials. Lesson 2 is called Factoring Polynomials, Round 2. What we're going to learn in this lesson is how to factor more complex polynomials. Here we go. Here's a couple examples. These are more difficult than the last lesson's examples because our x squared term has a number attached to it. In the last one, it always started with x squared. This time we're having bigger coefficients, or smaller. So for the first example, we have a 3x squared. So when we do our box, 3x squared is a prime number. So we do know that, we know how to break that up. It's x and 3x. However, whatever number, for figuring our 5, whatever number goes with the x gets multiplied by 3x when it goes into the box. And that's important because when we look at our constant term 5 and we figure out all its factors, it's only got one pair of factors, it doesn't matter where the 1 goes and where the 5 goes. Because wherever goes here, the 1 or the 5 gets multiplied by the 3. And so remember, it's the x terms inside the box that have to add up to be the middle term, the x. If I put a 5 where the 1 is and a 1 where the 5 is, you'd be saying 5 times 3x. That would be 15x instead of 3x. 15x is way too big to get 8. So it does matter a little bit more. Now, when we're solving these things, remember the clue is if you're dealing with plus plus, as in the middle terms of plus and the last terms of plus, we're dealing with both positive factors. So x plus something, x plus something. If we have a minus plus, that means we're multiplying two negatives to get a positive 5, and a negative minus a negative is going to be negative 8. So we're doing minus x minus. If the second term is a minus, that means one's positive, one's negative. Okay, and so now there's as far as solving the box goes for factoring these, there's not a step 1, step 2, step 3 brainless way of solving these. You kind of have to look at it like a puzzle. Now you're trying to figure out the missing pieces. The piece on the side times the piece on top equals the piece in the box, and the pieces in the box have to add up to be the final polynomial, or in this case our starting polynomial. And so you kind of have to work your way. There are tricks we can do to figure out where some of these pieces are. One of those tricks is right here. So there's a trick, for example, of finding the x boxes. If you take the first term and the last term and you multiply them together, 6 times negative 14 is negative 84. And you take the middle term, negative 5, and we look at negative 84 and negative 5, we say, what two numbers multiply to be negative 84, but also add up to be negative 5? Well, 7 times negative 12 is negative 84, but 7 minus 12 is negative 5. So 7 and negative 12 are the numbers we're looking for. So instead of guessing and checking here, because in this case, 6x squared, 6 is not prime. It could be 6 and 1, it could be 2 and 3, multiple choices. But this little shortcut here tells me, okay, 7x and negative 12x go in the box. And so now I know my 6x squared, now I know my negative 5 is 7 and negative 12, and my negative 14, this trick gives me every number inside the box. Well, then we just figure out the numbers outside the box and we're done. Sometimes, like maybe 84 is too big a number for you to figure out all the factors. If that's the case, you're stuck with guess and check. But if you can do this x method and say, okay, what two numbers multiply to be negative 84 but add up to be negative 5, then you can find the missing pieces of the box and then factoring becomes really simple. Okay, we have another example too. In this case, our x would be what multiplies to be 6 times negative 14, but also adds to be positive 17. Well, 21 times negative 4 is negative 84, but 21 minus 4 is positive 17. So this works. These x terms match. And then we can figure out the factors accordingly. Okay, so a couple other techniques for making factoring simpler. Example E, notice the coefficients 4, 12, and 160 can all be divided by 4. 12 is just 3 times 4, and 160 is 40 times 4. So what we can do is we can pull out a greatest common factor of 4. When we do that, we're left with a polynomial x squared minus 3x minus 40. And then we can factor that polynomial in the brackets separately. Pulling out the greatest common factor makes it easier to work with smaller numbers, makes it easier to factor. Example F, we're also pulling out a greatest common factor, but instead of a number for our greatest common factor, we're pulling out a variable. We're pulling out x's, because each term has at least 2 x's in it. So we can pull out x squared. If we pull out x squared, the remaining polynomial is x squared minus 14x plus 13, which is easier to factor. And we can do our box method accordingly. Okay, so we have a couple ways to factor. When we get to bigger numbers, we can either pound it out and try to figure out the box. We could use this x method, what multiplies to be the first times the last, but adds up to be the middle term. That's a nice trick. Or we can pull out a greatest common factor to make the factoring simpler. That's what we got for this lesson. So hopefully now we have some more confidence in factoring polynomials, and we have more confidence in factoring more complicated polynomials. And I'm filming this on Friday, right before Thanksgiving, so I hope you have some good Thanksgiving weekend vibes. Is that a thing? Thanksgiving weekend vibes? I don't know.